Hi guys, welcome back to our channel Chamaku Sparks. So ఇవాళ మనం ఇంటర్మీడియట్ ఫస్ట్ ఇయర్ చాప్టర్ 4 కెమిస్ట్రీ స్టేట్స్ ఆఫ్ మ్యాటర్ గ్యాసెస్ అండ్ లిక్విడ్స్. సో మనము అకార్డింగ్ టు బ్లూ ప్రింట్ మనకు ఈ చాప్టర్ నుంచి 2 మార్క్స్ క్వశ్చన్ ఒకటి వస్తుంది అండ్ ఆల్సో 4 మార్క్స్ క్వశ్చన్ కూడా ఒకటి వస్తుంది. సో ద టోటల్ వెయిటేజ్ ఆఫ్ దిస్ చాప్టర్ ఇస్ 6 మార్క్స్. సో మనము ఈ చాప్టర్ ఈజీగా కంప్లీట్ చేసేసుకుందాం. సో without any further, let's complete this chapter in a very easy and simple way. As you can see, first manam short answer questions complete cheskundamu, then we will go to very short answer questions. So first question, state and explain Graham's law of diffusion and its applications. So manaku first, what is Graham's law of diffusion? At constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. So this is the definition for the Graham's law of diffusion. So R is inversely proportional to 1 by root D. This is root D ante manaku, this is density, okay? So therefore R1 by R2 is equals to root D2 by D1, okay? Next one. The rate of diffusion of a gas is inversely proportional to the square root of its molecular weight. So here the rate of diffusion of a gas is inversely proportional to the square root of its molecular weight, okay? So R is inversely proportional to 1 by root M. So therefore R1 by R2 is equals to root M2 by M1, okay? So the last one, molecular weight is the twice the vapor density. So molecular weight M is equals to twice the vapor density. So 2 into Vd is nothing but vapor density. So therefore M1 by M2, so M1 by M2 is equals to vapor density 1 by vapor density 2 is equals to R1 by R2, therefore is equals to root D2 by D1 is equals to root M2 by M1 is equals to root Vd2 by Vd1, okay? So in the question there has been asked applications. So what are the applications of Graham's law of diffusion? It is used to separate uranium isotopes by forming volatile hexafluorides, and working of Ansell's alarm in coal mines is based on diffusion, okay? So moving on to the next question, deduce Boyle's law, Charles' law and Graham's law and Dalton's law in kinetic gas equation. So what is Boyle's law? So this is Boyle's law. It states that at a constant temperature, the volume of a given mass of a gas is inversely proportional to its pressure. This is known as Boyle's law. So according to kinetic theory, the average kinetic energy of a gas molecules is directly proportional to the absolute temperature. So here according to the law, pressure is inversely proportional to volume, okay? So pressure is inversely proportional to 1 by V. So kinetic energy is directly proportional to the absolute temperature, as you can see here. So kinetic energy is equals to kT. So therefore PV is equals to 1 by 3 mnV square. So multiply and divide on both sides with 2. So for this equation we have to multiply and divide on both sides with 2. So PV is equals to 1 by 3 into 2 by 2 mnV square. So PV is equals to 2 by 3 into half mnV square. So therefore what is kinetic energy is equals to half mnV square. In the place of half mnV square we are going to substitute Ke. So PV is equals to 2 by 3 Ke. So therefore kinetic energy is directly proportional to kT. So in the place of Ke we are going to take kT, okay? So PV is equals to 2 by 3 kT. So according to Boyle's law, pressure is inversely proportional to volume. So we will be taking this volume into the right side, okay? So P is equals to 2 by 3V into kT, okay? So now coming to the Charles law. So what is Charles law? So What is Charles' law? At constant pressure, the volume of a given mass of a gas is directly proportional to its absolute temperature. So it is known as Charles' law. So, according to kinetic theory, the average kinetic energy of a gas molecules is directly proportional to the absolute temperature. So, this is Charles' law, right? So, volume is directly proportional to temperature. So, therefore, pressure P is equals to 1 by 3 mnv square. So, therefore, kinetic energy is equals to kT, and PV is equals to 1 by 3 mnv square. So multiply and divide on both sides with 2. So PV is equals to 1 by 3 into 2 by 2 mnv square. So PV is equals to 2 by 3 into half mnv square. So what is kinetic energy formula? Half mnv square, right? In the place of half mnv square, we are going to take Ke, okay? So PV is equals to 2 by 3 Ke. According to Charles' law, the given mass of a gas is directly proportional to its absolute temperature, right? So therefore, volume is equals to 2 by 3p into K. Coming to the Graham's law of diffusion, what is Graham's law? At constant pressure and temperature, the rate of diffusion of a gas is inversely proportional to the square root of its density, as we already learned in the previous answer. So according to this kinetic theory of gases, R is inversely proportional to 1 by root D, and it's directly proportional to 1 by root M, which is molecular weight, and this is density. So molecular weight is equals to mn. So capital M is equals to small m and small n. So density is equals to mass by volume. Okay, so D is equals to m by V. So PV is equals to 1 by 3 mn u square RMS. Okay, RMS must be coming in the downwards. Okay, so URMS is equals to, we will be taking this PV to this side. Okay, so this will be coming here. Okay, so URMS is equals to 3PV by M. So therefore density is equals to mass by volume. Therefore we will be taking it as volume by mass is equals to 1 by density. Okay, so URMS square is equals to 3P by D. So 3 pressure by density. So therefore URMS is equals to root. The square will be going to that side, so it will become root. So root 3P by D. So therefore URMS is directly proportional to, inversely proportional to 1 by root D. So hence Graham's law in kinetic theory of gases, therefore here is solved. Now coming to the Dalton's law. What is Dalton's law? At constant temperature, the total pressure exerted by a mixture of gases is equal to the sum of the partial pressures of gases. So Pn is equals to P1 plus P2 plus P3 plus so on. These P1 plus P2 plus P3 are nothing but partial pressures of gases. Okay, gases. Okay, so now PV is equals to 1 by 3 mn u square RMS. So P is equals to, we will be taking this V this side. Okay, volume we will be taking on the right side. So pressure is equals to 1 by 3V mn u square RMS. So P1 is equals to, pressure 1 is equals to 1 by 3 m1 n1 u square RMS by V, and P2 is equals to, just the same formula, just add the numbers. Okay, so 1 by 3 m2 n2 u square RMS by V. P3 is equals to 1 by 3 m3 n3 u square RMS by V, and therefore at last we will be, P is equals to P1 plus P2 plus P3 plus so on, right? So just take this all formulas and just keep is equals to. Okay, that's it. Now coming to the last and most easiest answer of this chapter, that is, what is ideal gas equation? So what is ideal gas? By combining Boyle's law, Charles' law and Avogadro's law. Before going to the answer, let's learn what is Avogadro's law. So what is Avogadro's law? It states that at constant temperature and pressure, equal volumes of all gases contain equal number of molecules or moles. Okay, this is known as Avogadro's law. So by combining these three laws, we get an equation which relates to volume, pressure, absolute temperature and number of moles. This equation is known as ideal gas equation. So what is the formula of Boyle's law? Volume is inversely proportional to 1 by P, that is pressure. This is the Boyle's law formula. And what is the Charles law formula? Volume is directly proportional to absolute temperature. This is Charles law formula. And coming to the Avogadro's law formula, volume is directly proportional to number of moles. So this is the formula of ideal gas equation. This is the ideal gas equation. PV is equals to nRT. So where P is pressure of the gas and V is volume of the gas and N is the number of moles of gases and R is universal gas constant and T is the absolute temperature. So if you know the ideal gas equation, you can easily write the ideal gas definition as well.